This is concerning the recent Genoa bridge collapse and bridges in general. Maintaining these structures is a constant battle against traffic and decay. Marios Chrysanthopoulos, professor of structural systems, University of Surrey, explains for us. The recent Ponte Morandi bridge in Genoa collapsed, claiming at least 36 lives and 12 missing. And rescue workers are still looking for survivors. They're still looking for survivors in the concrete rubble that used to be part of the Morandi bridge in Genoa. The Italian authorities are starting their investigation into the possible causes behind this terrible tragedy. It's too early to determine what may have caused the catastrophic collapse of more than 100 meters of the multi-span, cable-stayed suspension bridge, completed just over 50 years ago. It was built in the 1960s. But it's important to understand that bridge engineering does not end when construction finishes and traffic starts to flow. In fact, properly looking after a bridge during its long life is as crucial as having a good design, using high-quality materials, and ensuring sound workmanship during construction. Modern bridges are designed for a life of 100 years. Though many centenarian bridges, such as the Forth Bridge in Scotland, which opened in 1890, still provide sterling service, and of course there are smaller bridges built of stone to more ancient designs that have stood for many hundreds of years. Considering the number of bridges built in Europe during the expansion of the motorway network from the late 1950s onwards, we should expect and be prepared for many to exceed their planned lifespan in coming decades. Facilitating this is ambitious but necessary and made possible thanks only to regular inspection and maintenance that ensures that building materials have not degraded and that structural elements are fit to bear the traffic and environmental loads that they face. So what are the factors that affect the strength of a bridge and may compromise public safety? Environment and climate. The climate in a bridge's location, taken alongside atmospheric pollution common in cities, can have an adverse influence on the materials of the bridge. For example, the corrosion of steel reinforcement or press-stress steel tendons embedded in concrete. Regular inspections are typically scheduled every 6 years for large bridges to identify any degradation and to take appropriate measures to replace cracked concrete and corroded steel or to introduce protective coatings. In England, the Midlands Link motorway viaducts, comprising 13 miles of elevated motorway carrying the M5 and the M6 motorways around Birmingham, suffered from chloride-induced steel corrosion early in their lifespan, life from exposure to salt used to de-ice the roads. This required an extensive application of corrosion protection measures in the early 1990s. More than 700 structures have benefited from this action, demonstrating the cost savings that can be made if appropriate action is taken at the right time. Stress and fatigue. Fatigue caused by use is another factor, and inspectors will look out for telltale signs of failure often associated with the cyclical stress produced by passing vehicles, particularly heavy trucks. This type of failure is especially relevant for metal bridge decks and the cables of suspension and cable-stayed bridges. Traffic has increased ever since these bridges were built, which inevitably leads to the need for more maintenance and strengthening work, such as additional steel, glass, or carbon fiber reinforced plates on critical parts in order to restore or enhance their strength compared to what was deemed necessary during their design. For example, Network Rail in the UK used fiber-reinforced polymers to strengthen more than 20 bridges carrying highway or railway traffic between 2001 and 2010. Consider how we all tend to react to a road sign bearing the words, "Essential bridge works. Expect long delays." One such situation prompted this comment from a member of the public, quote, "We are doomed. I'm going to buy a tent and pitch it outside work for the 3 months while the misery goes on," end quote. Perhaps knowing why this is necessary and the consequences of not doing so, it might persuade people to consider and reconsider such views. Money and willingness to spend it. Equally, we must understand that maintenance budgets need to be set at levels that far exceed those that would allow engineers only to firefight the most severe problems, as is becoming worryingly commonplace. Instead, budgets need to allow for planned interventions and necessary upgrades over many decades. That requires public and government support, as well as skilled engineers committed to ensuring the safety of an aging structure. There are challenges in devising improved methods to assess bridge strength, developing new repair techniques, and new ways of collecting and using inspection and monitoring data to provide advanced warning of problems. These constantly push technological boundaries, making it possible to operate existing bridges safely during their long service lives. And the experience gained feeds into new designs that will become reality in years to come. Those investigating the collapse of Morandi Bridge will look at inspection and maintenance matters. Other lines of inquiry will no doubt include the unusual design of the multi-span bridge with only a few cable stays to transfer deck loads to the tower, the ongoing work to shore up the foundations, and the heavy rainfall at the time of the collapse. In the shadow of this terrible loss of life, it's worth remembering that bridge inspection and maintenance may be annoying for commuters, but that it is crucial. This is on The Conversation. Kindly support by contributing to my Patreon account. You'll find it in the description box below. Thank you.